Hi, I'm Craig. This is Get Smarter and Make Stuff. Welcome to the shop. Well, today I'm going to make use of my CNC router, but in kind of an unusual way. Going to do a favor for a friend and thought it'd be a good excuse to show you a technique that I've been using that I kind of like, even though it's a little bit weird. Let's get started. We're over here at my CNC router today because I've got a project I want to work on that I think I'm going to make use of it in kind of an unusual way. So the project is a friend of my wife's came to us and asked us if we could put a groove in this dollhouse part. There's currently a groove that runs down this side, and for whatever reason, I'm actually not quite sure, they need a groove down this side as well. I think they're trying to reconfigure it a little bit. I've gone ahead and marked the lines that we know in there, and it would be pretty straightforward to, if you can see that or not, there's just a little, let's use a marking gauge to transfer the marks to the side. So that would be easy enough to do in a number of ways. I could do it with a chisel. I could do it maybe with a router plane. This is actually a pretty narrow groove. I think it's 6.5 millimeters, so it might be a little tricky to get a router plane in there. I don't know if I have one with a blade that narrow. Or I could use a trim router like the one I have in my CNC router and just do it by hand. All of those would work. I'm going to use a slightly different technique that I have kind of grown to like for routing grooves like this in dados. I haven't used it a whole lot, but the few times I've used it, it's been successful. And the basic idea is that we're going to mount the piece on the CNC router, and then the CNC router, which actually I need to turn this off to show you. The CNC router is got motors that allow it to move in 3 dimensions, up and down, and then X and Y. And it's powered by stepper motors that drive it in each of the directions. And the thing is, right now, since the power is off, they can move freely. I can move it in X, I can move it in Y, I can even, you won't be able to see this, but I can turn the screw that's in the Z direction and move it up and down. But when it's on and you provide power to the stepper motors, it'll hold. It'll prevent it from moving in that direction. And in fact, when you initially turn the router on, what you'll find is that you can still move it because the steppers are disabled when it comes up. But using this little control panel I have here, you can move the individual dimensions to get it where you want. And the minute that you move it in one direction, so let's say I move it in X, which on this machine is this way, the minute I move it in X, the steppers will hold that position. But if the other motors are disabled, I can still move it in Y, which is to say, let me step over here. If I enable the X motor, it'll hold, it'll stop me from moving it this way, but I'll still be able to move it in the Y direction. And I can do the same thing for Z, and what that means is that I've basically got a router that's on rails, and I can fix it in one direction and sort of hand plow a groove this way. Now you might be asking yourself, well, why wouldn't you just use the CNC capabilities to power it along? And the answer is because then I have to write a program. I mean, I might use something like Fusion 360 to generate that, but I've got to go over to the computer and generate the code and come back and make sure it's right. And for something simple like plowing a groove, really I can just eyeball it to where I want it to be, get it in position, and then run it by hand. And actually that is nice too because it allows me to use the feedback of how the cut is proceeding to slow down or speed up so that there's no chatter, so that I'm not pushing it too hard. And I've used this a couple times with good success, so much so that when I have a bigger shop, one of the things I'd like to do is make a setup where I have a router that's just on rails in a fixed direction. It's not CNC control, but you could lock it down using a fence system of some kind and then actually move the router along, kind of like a track saw, but for a router. I don't know if these things exist already. I haven't really looked. It's just something that I've been thinking about. But I will use my CNC router to do that. So let me get the cameras repositioned so you can see what's going on, get my safety equipment on, and we will go ahead and get started with the cut. All right, I've got everything attached to the work surface. I know it's a little hard to see. It's very difficult to get the cameras in here in a way that lets you see everything that needs to be seen. Go ahead and attach this workpiece very firmly to the table using my favorite mechanism of just screwing things directly to the work surface. Got some blocks of wood in here holding it down. I think it's good to go. So the first thing to do is to go ahead and power up the system without powering up the actual router itself. That will enable the control logic and for me to drive the stepper motors to where they need to be. So I think you can see this okay on the screen here. So, okay. So like I said, what we're going to do is we're going to go in and just move the axes that we care about, and that will allow them to stay in place. So right now, I can move this around in every dimension, but as soon as I move it, well, I got to make sure I bring this over to the side, because if I start it too far in positive x, once I move x, it's going to set that as the 0 point, and I won't be able to move to negative values. It doesn't let you do that. All right, so if you heard that, there was a little bump, and now I can't easily move the router in the x direction. It's not in the right place yet, but that's fine. Let's go ahead and take care of z. So we'll do the same thing. Z, you can move negative for perhaps obvious reasons that you need to be able to do that. Okay, great. Now we're fixed in x and z, so now we can go ahead and establish our 0 point. I think I'll need to go to x and do that first. Let's go ahead and move that over to where it lines up with our marks. And I know you probably can't see this, but I'll just have to take care of it real quick. Okay, still not quite there. All right, looks pretty good. Let's go ahead and get Z moved down so we can kind of touch off and get our initial position going. Still loose. Still loose. That's real close. In fact, I can hear it rubbing, so we'll call that 0. Okay, and so now let's make sure our X position is right. We're not quite there yet. Let's move our X to just a little bit farther positive. And that's real close. I'm going to switch to 0.1 millimeters. All right, I think that is going to do it. That's maybe just a tiny bit more. It's really lovely to be able to move this in 0.1 millimeter increments. Quite an accurate cut that way. Okay, so we're good. I'm going to go ahead and lower Z just a little bit so that we can make a cut, actually. Not much. I think we'll just try 1 millimeter to start with to see how it looks. Okay. All right, so let's put that down. So now we're free to move in Y, fixed in X and Z. So next thing is get our safety equipment on, power up the spindle, and make a cut. Oh, that would be this switch. Looks good. All right. And I happen to know, turn that off so you can hear me better. I happen to know that we need to move X by, I wrote it down. Don't be a dummy. Where did I write it down? And I wrote it down on a piece of board that I then covered up. It's 1.5 millimeters, though. Move X. If I move X 1.5 millimeters, 1, 2, 3, 4, 5. It's now in the right position to make the rest of the cut so that the slot will be the full width. The width of the bit plus 1.5 millimeters is the width of the slot we need. Let's fire it back up. Come back the other way. And I can see that's not quite right. In fact, I can see that we are not parallel to the edge, which I'm not sure how that happened. All right, we'll have to stop there and I'll try to figure out what's going on. Okay, I think I got it figured out. Not sure how, but the whole thing was just shifted off a little bit so that the direction I was moving the router was not parallel with the direction of the edge of the workpiece. So just shifted it over a little bit, verified that it looks good. Going to go ahead and give this a try again. All right, so we're looking for 5 millimeters on the depth. We're not there yet. We can go ahead and move Z down a bit, take a cut. Take it down another 2 millimeters. And here we go. that looks not that great, to be honest with you. It's still kind of drifting over a little bit. It's better than it was, though. I think we might just have to call it good enough. All right, well, let's move X over a bit. I wrote this right exactly. I wrote down my note right exactly underneath where I screwed down a holding block. So I actually do want to reference my note there. 2.5. According to my note there, the problem with using scrap is I pick it up and use it for more than one thing. I need to move X over 2.5. I just moved it 2, so 1, 2, 3, 4, 5. Okay, so that should do it on the other direction. Okay, let's see how we're doing. Not quite 5 millimeters deep yet, and I think we are a little wider than our target, which hopefully is okay. Yeah, we're at what is that? Hard to see in the camera for me, but about 8 millimeters, and we're shooting for 6.5. I think that's probably okay. Not awesome, but when we're going for, let's measure this other side again. We want it to be, I make that 5 millimeters deep. We're at about 2, so let's go down another 2 millimeters. Two millimeters down, make another cut. And of course, you all saw where I set down my calipers, but it being 3 seconds ago, I can't remember. Here they are. So let's check where we're at for depth. 5 millimeters. All right, so that's good. So we just need to come back in X 2.5 millimeters and finish the cut. So we're going to go move X negative 2.5 millimeters. So down 1, down 2. 1, 2, 3, 4, 5. All right. And fire this guy back up. All right, let's check our width. At the bottom, it is 6.5. That's pretty good. Actually, yeah, right on. Yeah, so not super thrilled with how that went. Not sure where the non-parallelism came from. I do still like having the router on guides, basically. Like this motion makes it really nice. My hands are way away from where the cutting is happening. It's pretty easy to get things fixed in place. Again, not the ideal setup in terms of using the CNC router. For one thing, this is the MP CNC, the mostly printed CNC. I should have mentioned that before, which is a really cool project. But it is, 3D printed parts, and it's not the most rigid thing in the world. You might even be able to see me able to move just a little bit, and the tool pressure definitely is enough to deflect it a bit. Fine for what we're doing here, but if I had something more rigid, they could be entirely fixed in to slide just in one dimension and adjustable in the other two. I think I can make a pretty nice setup. That's a project for some other time, though. I think we're going to call it there today. Call this one done. Get this piece to the lady that asked for it. Maybe I may go in there a little bit and clean up with a chisel. There's a couple spots that are a little got a little bit of a lip left. No big deal, I think. And hopefully it's good enough for her. Certainly apologize if the routing job is not quite what she was looking for, but I think it'll serve. That's all for today. If you find my flailings entertaining or maybe even educational, I'm not sure about that, but you want to go ahead and click that like button, that'd be great. Certainly appreciate that. What helps even more is if you click subscribe, or better still, leave a comment. First of all, I love to hear from you. Any of you have anything to say? Like, I'm sure some of you noticed that I was doing a climb cut on some of those instead of a conventional cut, and didn't seem to make too much of a difference, but love to hear your input on that. If you've got an MP-CNC and you've ever considered using this way, or if you haven't, love to hear about that too. Just yeah, leave a comment down below if you feel like it. If not, no big deal. Certainly appreciate you watching, and we'll catch you next time.